The James Webb Telescope represents one of the greatest advances in astrophysics and never ceases to amaze. Recently, this telescope has made a new discovery in our solar system. Although the solar system has not undergone significant changes over the years, familiarity has led us to mistakenly believe that we have discovered everything in it. But in reality, space continues to expand and new objects are appearing. The James Webb Telescope has captured some of these newly discovered objects. Michio Kaku, a renowned American theoretical physicist, also expresses amazement at these new and unknown objects traversing space. Given the appearance of these objects, the question arises as to whether this portends something positive. What is certain is that this marks a new stage of learning in the world of physical science. Join us as we explore the details of the 500 new objects recently detected by the James Webb Telescope in space. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it so it reaches more people, and turn on the notification bell. NASA, the European Space Agency, the Canadian Space Agency have teamed up to give astronomers an unprecedented gift, the James Webb Space Telescope. This extraordinary gift offers them the opportunity to observe the past in its early stages and, we can say, witness the very creation of the universe. Astronomers around the world were transported to the limits of time thanks to the James Webb Telescope, which has been hailed as the most outstanding stellar observatory of the next decade and one of the greatest scientific achievements of our time. This telescope has opened the doors to outer space and taken us to the origins of everything. With its low Earth orbit, the James Webb Telescope has captured numerous images of the most distant regions of the universe, offering views never before witnessed. Like the Hubble telescope, it has succeeded in capturing the historical periods of our universe, examining the history and evolution of countless galaxies, stars, and nebulae. Scientists working with the James Webb Telescope have announced a fascinating discovery. When they began collecting data using the new Deep Field Telescope, they realized that there may be many more distant galaxies than they had previously anticipated. This gives us valuable information about how the universe is producing galaxies at a faster and earlier rate than previously thought. It turns out that just a few 100 million years after the Big Bang, many galaxies already existed. James Webb has given us access to observe how it all began. Some scientists have even suggested that galaxies may have begun to form only 100 million years after the Big Bang, which occurred nearly 14 billion years ago. This discovery challenged astronomers' existing theories about how and when galaxies formed, which is one of the features that makes the James Webb Telescope far superior to the Hubble telescope. One of the most outstanding advantages of the James Webb Telescope compared to the Hubble telescope is its size. The James Webb has a 6.5-meter mirror composed of 18 golden plated hexagonal pieces. This allows us to capture light from objects 6 times more efficiently than the Hubble telescope's 2.4-meter diameter lens. But the James Webb's greatest advantage over Hubble lies in its high sensitivity to infrared light. This telescope can detect wavelengths in a range from 0.6 to 28.5 micrometers, covering the middle to the red end of the infrared spectrum. This significantly expands our ability to explore and understand the universe in different bands of light, revealing details and phenomena that were previously hidden. The James Webb Space Telescope plays an essential role in uncovering the many mysteries of the universe by capturing the spectral signatures of celestial events. These telescopes allow scientists to explore extreme environments that give rise to these cosmic phenomena. One of the most intriguing enigmas that has emerged is the appearance of unknown objects in our solar system. Although it is normal for our solar system to receive occasional visits from objects like Oumuamua, we have never before witnessed such a remarkable influx of stellar visitors. This sudden increase in visitors and the discovery of 5 new unidentified objects in our solar system had left many scientists and astrophysicists puzzled. These celestial bodies pose an intriguing mystery to scientists. Despite rigorous observations and analysis, they have yet to be identified and categorized. However, they still represent a fascinating variety of celestial entities, ranging from the most familiar asteroids and comets to unknown and potentially novel objects that have found their way into our universe. The sheer diversity and quantity of these unidentified objects offer an exceptional opportunity for scientific exploration and discovery. Despite the challenges they represent, they are a promising field of study that can provide valuable insights into our solar system and beyond. At the same time, these unknown objects could pose significant threats. That is why the importance of the James Webb Space Telescope lies in its ability to unravel the formation and evolution of our solar system. By studying trajectories, properties, and composition of these new objects that have appeared in our cosmic neighborhood. Analyzing the physical characteristics of these unknown space-crossing objects would help us gain valuable insights into the process that has shaped our solar system over billions of years. In addition, by examining their orbital patterns and gravitational interactions, scientists could better understand the complex dynamics that have influenced the formation and behavior of these objects that now call our solar system home. In addition, going beyond our own solar system promises a deeper understanding of the formation and evolution of other solar systems. With this knowledge, researchers will be able to draw parallels and comparisons with objects observed in distant stellar systems. The detection of these objects may also contribute to our understanding of the distribution of matter in the universe. Examining the location of the orbits and the properties of these new stellar objects is crucial for astronomers to redefine existing models and theories about the large-scale structure of the cosmos. These observations give us valuable insight into how matter is distributed on a universal scale, which expands our understanding of the composition and organization of the universe. Interestingly, the detection of these objects may provide relevant information about the nature of dark matter, one of the most enigmatic components of the known universe. Dark matter constitutes a significant portion of the total mass of the universe, and understanding its interactions and effects on its environment is fundamental to obtain clues about its presence and behavior. Through this research, we can now contribute to solving the present mystery of dark matter and improve our understanding of its properties and its role in the universe. The detection of these 500 unknown objects in space may also shed light on the nature and influence of dark energy, which is the driving force behind the accelerating expansions of the observable universe. While the discovery of 500 new objects in our own solar system is exciting in its own right, it raises questions about their origin. One of the most intriguing theories suggests that they may have been ejected from black holes. Black holes are one of the most fascinating phenomena in our cosmos and, to a large extent, remain an enigma to us. They are celestial entities formed by the collapse of massive stars and possess such a powerful gravitational force that they can disrupt nearby objects and hurl them farther out into space. If these unknown objects ejected from the solar system due to the influence of a black hole, it would be a testament to the enormous power that these cosmic objects exert. Black holes not only have the ability to swallow unfortunate bodies in their wake, but also eject material that has not yet entered the event horizon layer, like a space tornado. The intense tidal force exerted by black holes can tear apart stars or any other planetary body, creating a tumultuous environment in which fragments are violently ejected. In this sense, the question arises as to whether black holes have the capacity to also eject materials that have been trapped inside them, rather than holding them infinitely. This scenario raises a fascinating possibility that black holes are not only devourers, but also drivers of matter into commuting space. The discovery of the James Webb Space Telescope has shaken the foundations of our cosmic understanding, challenging established rules and revealing hidden mysteries of the cosmos. This unprecedented breakthrough has generated palpable anticipation in the scientific community, as each observation provides new insights into the universe and its deepest secrets. The massive object recently detected by the JWST raises questions about the origin of the universe, and its identity remains a fascinating enigma. This discovery revolutionizes our perception of the cosmos and invites us to explore new horizons of understanding. Join us as the James Webb Space Telescope takes us on a journey through time, revealing cosmic secrets that defied our imagination. On December 25, 2021, humanity took a leap forward in space exploration with the launch of the James Webb Space Telescope, the JWST. This cutting-edge instrument in cosmology and infrared astronomy has opened up new possibilities for studying distant stars and galaxies, providing exceptional resolution and sensitivity. One of the JWST's most outstanding achievements is its ability to observe the cosmic past, allowing us to study the first stars and galaxies, as well as to accurately analyze the atmospheres of exoplanets and the enigmas of black holes. These cosmic phenomena, formed by the gravitational collapse of stars, represent areas where the laws of space and time are extremely distorted, challenging our fundamental understanding of the universe. The event horizon, known as the point of no return, is a region that challenges the fundamental principles of modern physics. Although black holes are relatively recent discoveries, the theory of relativity had suggested their existence for long before they were directly observed. This theory postulates that sufficiently dense masses can be bent space-time, giving rise to strange structures that we call black holes. The reality of black holes, initially invisible, becomes evident thanks to their gravitational effect on the surrounding environment, including space satellites and nearby materials. Scientists use a variety of sophisticated instruments to detect evidence for the existence of a black hole. They observe how nearby stars and their surrounding gas are affected, analyzing gravitational effects to determine whether they are orbiting the black hole or being ejected by its immense gravitational pull. The James Webb Space Telescope, equipped with advanced tools, allows us to probe deeper into the universe and tackle problems once thought to be indetectable, such as the nature of black holes and nearby stars. When objects approach a black hole, they radiate large amounts of energy, illuminating the galactic scene. However, despite their dramatic impact on their surroundings, black holes remain enigmatic as to their dimension, as their precise size remains undefined, as predicted by the theory of relativity. This is because the gravity of the black hole determines the fate of any object that comes too close, and the hairless theory further explains this mystery of black holes. The theory suggests that once a black hole reaches stability after its formation, it has only three measurable properties: mass, electric charge, and angular momentum. However, this apparent simplicity masks the inherent complexity of these cosmic phenomena, making it difficult to distinguish between black holes that may have similar physical characteristics. Examining the types of black holes reveals a diverse family of distinctive characteristics. The first type of stellar black hole, which is the smallest and has a mass between 1 and 100 times that of the Sun. On the other hand, there are supermassive black holes, which can weigh millions or billions of times the mass of the Sun. It is believed that the death of massive stars in the early universe gave rise to these supermassive black holes. In the middle range, there are intermediate black holes, which lie between stellar and supermassive black holes. Contrary to popular belief, some black holes can be relatively small, reaching the size of an atom. It is difficult to imagine that such massive stars could collapse to such a tiny size and at the same time maintain such a gigantic mass. However, the reality is that in the Milky Way and in the universe in general, there are a multitude of scattered black holes, each with a mass equivalent to millions of times that of the Sun. Theoretical and empirical observations have shown that the largest black holes tend to occupy a central position in galaxies, including our own Milky Way galaxy. At the center of the Milky Way resides Sagittarius A supermassive black hole with a colossal mass equivalent to about 4 million suns. This makes it the most massive object in its galactic environment. Ongoing research of black holes begs the question, what makes them so fascinating? The inherent complexity of these entities has kept scientists busy for decades. Black holes are truly cosmic laboratories that challenge numerous theories rooted in the general relativity and quantum mechanics. They also offer opportunity to explore unknown areas of physics, expanding our understanding of the fundamental principles of the universe. However, our understanding of black holes remains limited because we cannot observe them directly. Stellar mass black holes, for example, reach temperatures in the billions of Kelvin, which limits us to using indirect methods and theories to study them. At the heart of the intrigue surrounding black holes is the event horizon, a boundary in space-time from which light cannot escape. This fundamental feature not only denotes the gravitational power but also represents a domain of reality beyond our human comprehension. As we approach the event horizon, the laws of physics undergo profound change, but it still offers a window into the mysteries of these phenomena. While we understand how some black holes form as a result of the gravitational collapse of massive stars, the exact process remains a subject of study. Scientists point to the importance of high-density environments such as those within stars for this type of collapse in today's universe. However, during the early stages of the universe, the extreme densities of the Big Bang significantly increased the probability of black hole formation. In addition to high densities, black hole formation requires an uneven mass distribution to prevent mass from becoming uniform. In such dense environments, it is believed that there was initial fluctuation in density that allowed black holes to grow through gravity. Gravitational collapse is not only the way black holes can form, high-energy collisions can also create them if the density reaches sufficiently high levels. However, since 2002, no such event has been detected, either directly or indirectly, although hints of mass imbalances have been suggested in particle-accelerated equipment. What is fascinating about black holes goes beyond their formation. Their dynamic nature is intriguing. They have no defined sizes and can continue to grow without limit by absorbing surrounding matter, such as space gas and dust. This ability is responsible for the creation of supermassive black holes and has been posed as a pathway for the formation of intermediate black holes in globular clusters. Black holes can also merge with other objects, such as other stars or other black holes, to form gigantic black holes. Despite these complexities, black hole formation remains a subject of study, and with the operation of the James Webb Space Telescope, we are poised to discover more details. However, there have been concerns about the possibility of a black hole impacting Earth and destroying it. However, scientists have ruled out this possibility, demonstrating that a black hole of the same mass as the Earth would not suck it in, but would rotate around it due to its equivalent gravitational attraction. In addition, black holes do not move through space consuming celestial bodies, so the Earth would not succumb to a black hole due to its remoteness from our solar system.
In a surprising turn of events, NASA's James Webb Space Telescope has made a discovery that has astronomers around the world in awe. A few weeks ago, the telescope discovered the earliest known galaxy in the universe, but it now has detected something even more massive, a supermassive hole moving away from its galaxy at an incredible speed of 4 million miles per hour. This latest discovery has very important implications and has generated much speculation among scientists and space enthusiasts about what it means for our understanding of the cosmos. The James Webb Telescope was launched on a mission to explore the first stars and galaxies in the universe and has captured stunning images of the death of stars and galaxies from a few 100 million years after the Big Bang. We invite you to join us to explore the latest discoveries from this telescope. If you are interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel, be sure to like this video, share it to reach more people, and turn on the notification bell. The latest discovery is challenging the scientific community's current understanding of black holes. Black holes are generally thought of as huge entities that pull everything, including light, towards them. But the recently observed black hole appears to be having the opposite effect. Instead of absorbing light, it is creating new young stars along a trail. This new trail of newborn stars has been observed in the wake of the black hole, which stretches an incredible 200,000 light-years away. Scientists are puzzled by the unusual behavior of this black hole compared to others, but a team led by Yale astronomy professor Peter Banda recently reported their findings in the astrophysical journal, the Journal Letters. NASA's Hubble Space Telescope also confirmed these observations, suggesting that the black hole awakens new stars when it comes into contact with gas and cools it. We are seeing the wake behind the black hole, but that's not all. NASA has made an exciting announcement about the galactic merger of 220, which was captured by the James Webb Space Telescope. This impressive galactic merger can be seen shining among other galaxies in the night sky. When two spiral galaxies merge, the phenomenon known as ARP-220 shines the brightest in the infrared, making it perfect for observation by the James Webb Space Telescope. It is classified as an ultraluminous infrared galaxy with a luminosity of 1 trillion suns compared to our own galaxy, the Milky Way, which has a much lower luminosity of about 10 billion suns. ARP-220 is located in the constellation of the Serpents, about 250 million light-years away. It is considered the brightest of the 3 closest galactic collisions to Earth and is listed as object number 220 in the Atlas of Peculiar Galaxies. About 700 million years ago, 2 spiral galaxies collided and triggered a huge explosion of star formation. This created a dense region about 5,000 light-years across that contains about 200 large star clusters. Surprisingly, this small area contains as much gas as the entire Milky Way. Previous observations with radio telescopes discovered about 100 supernova remnants in less than 500 light-years across. Then, the Hubble Space Telescope revealed that the parentals galaxies are located 1,200 light-years apart, and that each core contains a rotating ring of star formation that emits dazzling infrared light. This latest view from the James Webb Space Telescope shows an impressive galactic merger of the 2 galaxies. This image also shows faint tidal tails extending from the outskirts of the merger, indicating the gravitational pull between the 2 galaxies. Finally, the reddish and orange streams and filaments represent scattered organic materials in ARP-220. Another stunning discovery stumped scientists. When researchers found primordial galaxies at the edge of the universe, they were skeptical about their authenticity. Some thought they might be nearby galaxies in disguise. So they shared the data with other scientists around the world, hoping for the best. Amazingly, the James Webb Space Telescope confirmed that these ancient galaxies are real. Thanks to this revolutionary telescope, we can now observe the oldest galaxies ever seen. Astronomers estimate that light from these galaxies has traveled more than 13.5 billion years to reach Earth, giving us a glimpse into the distant past of the universe. These galaxies were discovered when the universe was only 350 million years old, shedding light on how quickly the first generations of galaxies emerged. Spectral data confirmed that these galaxies are at the edge of our view, some even further away than Hubble could see. This discovery is crucial because it validates one of the most important tasks of the James Webb Space Telescope, which is to study the early universe through light that has been traveling for more than 13.5 billion years. The ability to measure extreme redshifts is what sets James Webb apart, allowing astronomers to peer into the infrared range and observe the earliest galaxies in the universe. The excitement in the air is palpable as this discovery marks an important milestone in the exploration of the universe and in the understanding of its evolution. This discovery has had a major impact on our understanding of the universe and has motivated NASA to develop even more powerful telescopes than the James Webb Space Telescope to confirm whether our understanding of the Big Bang is correct. Data obtained from Webb's F spectrometer and near-infrared camera have revealed that 4 of the 6 primordial galaxies have extreme redshifts, suggesting that Webb is observing them as if they existed 300 to 500 million years after the Big Bang, without heavy elements such as carbon. This is surprising, since the universe is estimated to be 13.8 billion years old, and the existence of these galaxies suggests that we need to revise our understanding of the early universe. This has generated concern in the scientific community, as these new discoveries challenge the current cosmological inflation model and the Big Bang theory, which has some loopholes, such as going against the law of thermodynamics and not having a clear explanation of what caused the Big Bang. In addition, the James Webb Space Telescope is discovering galaxies almost as old as the Big Bang itself, which questions everything we thought we knew about the origin of the universe. According to theoretical physicist Michio Kaku, the discovery of ancient galaxies by the James Webb Space Telescope has called into question everything we knew about the beginning of the universe. Previously, these galaxies were thought to be less developed than the Milky Way. But the new findings suggest that we may be missing crucial information. The fact that the telescope has identified 6 galaxies that exist 500 million years after the Big Bang and are up to 10 times larger than the Milky Way raises the question of whether our current theories about the creation of the universe are correct. Kaku explained that it takes billions of years to create a galaxy like the Milky Way, so it is strange to find such large, young, primordial galaxies. This discovery may require us to revise and rewrite textbooks on the beginning of the universe. The James Webb Telescope findings challenge what we thought we knew about the Big Bang, leaving scientists at a crossroads. Despite this, NASA recently tweeted about a galaxy cluster that lies just 650 million years after the Big Bang, adding another intriguing piece to the puzzle. Astronomers have analyzed the data and concluded that this fledgling cluster is expected to grow in size and become something similar to the colossal Coma A1656 cluster. The place where all this is taking place is unique and special, as it is an area of accelerating galactic evolution thanks to the James Webb Telescope. Now, researchers can measure the velocities of these 7 galaxies, which gives them the confidence to confirm that they are bound together in a proto-cluster. To put this in perspective, NASA scientists compared these distant galaxies to small drops of water in different rivers that will eventually join together to form a large and powerful river. Clearly, what we previously believed about the Big Bang is not adding up as expected. However, more data from the Webb telescope may reveal evidence that could confirm or disprove the theory. Who knows, maybe the Big Bang did happen, but what caused it is a different story. In any case, we will have to wait for more discoveries, but the answer may be closer than we think. What do you think about these discoveries? Share your thoughts in the comments box.